In last lecture, we saw behind the pipeline. It was a three-step process. Tokenize maps a word to a unique number. Then we take that number and into that number, we try to map its meaning, semantic meaning, that's embedding. And further, it goes into model and we post-process models output. So tokenizer model and model output processing, three things. Let's take a look at model it at a tiny bit more detail. The way transformer library is designed, okay, it has this concept of head used quite a bit. So what does it look like? You have a model, okay. In the model, you have the body of the model whose job is to read the data, convert it into words, convert it into meaning, convert that meaning of words, and then extract the meaning of the even sentence. Okay, that part is done by body. It is supposed to extract all the intelligence present in the data. That's why it is a lot more general. We can use that output for many different kinds of tasks. So that is the output of hidden state. And then on top of the model, this, which is the body, we have different heads. I could have one head corresponding to just sentence classification. I could have one head corresponding to, let's say, text generation. I could have one head corresponding to maybe some other kind of problem. So you see, body remains the same. I can customize the head. I can swap. I can add different thing, and then I kind of like process the model's output. So this flexibility of having a body and then attaching different head, or taking this output of hidden state and adding your own few layers and then adding a new head, anything goes. This is how transformer does things. Okay, anything goes. So what was the step one of the pipeline? I have imported transformers library. Okay, it enables me to say everything, say transformers dot, I want, let's say, BERT tokenizer. I say BERT and automatically the autocomplete should have given me, but it hasn't. Anyways, okay. So generally it is BERT, whatever the model name, which BERT and GPT. So I say tokenizers dot BERT tokenizer and just fast, it's fine. And then from pre-trained, to get the pre-trained model for this specific checkpoint. Okay, executed. This tokenizer, which was trained by Google, which maps words to numbers in a specific way, it has mapped these two sentences to numeric formats in PyTorch like this. This is sentence number one. This much is sentence number one. And this much is sentence number two. So play with the sentences here. Try to understand tokenizer. What does it do? So let's say I and I say this here I. Okay. What does this thing tell us? What is the output? 101 146 101. And here also 101 146 146 102. We can immediately understand one word is being mapped to a one this thing. Now I wonder, if I say small I, is it mapped to the same thing? Now that is a good question, is it not? And I want to just print the input IDs alone. So you see, if I have, one capital I and one small I, in the printing of numeric IDs, first number is using 146 and second is using 178. So apparently this distinguishes between capital I and small I. You should be able to investigate the things. Now you go down. So this was just a tokenizer, right? Because we already saw how to use it last time, just a tiny bit investigation. Now model. A model we saw that is made up, we can instantiate as an auto model. So the auto model has that same thing we talked about. It has this. It has model input, model body, then head for whatever the task, and for auto model, you can have, attach your own head. You can also use auto model for that specific task. Then it comes with its own head, which is configured, or you specify the model here yourself. Before doing that, in Hugging Face, you always have a configuration of the model. Why do we initialize configuration first? Because model definition doesn't change. With configuration, we can change how big or small of the model are we instantiated. So this gives us flexibility. So I just say config and I say, you know what, I don't need a huge model. I just want a smaller scaled version of whatever the Google's model is. So configuration, I can adjust it, and then I use this configuration to create a model. And if I want to get a pre-trained model, I say from pre-trained and I get the pre-trained model. Done. So I just give tokenizers output to this, and architecture is kind of like used to do prediction. Just like this, also now investigate this model's architecture. So I'll do this simply by printing models variable, you will get the architecture. The architecture is like this. It has something named embeddings. Then it is word embeddings, and you see this nesting. This whole thing is just word embedding. So we know the word which is mapped to a number, it is mapped to meaning here. Then in encoder, it is converted to something. We don't need to understand its internal details immediately. We just know that it is a PyTorch models. There are apparently 11 layers, and it gives us the output. And here we can see the output final this thing. The total number of out features is 768. So this is the model definition. Okay. Now I want to see if that is actually true. And remember config. So I just say model pretrain.config to see the actual configuration of the model and see if 768 is present in it. I found that in the architecture, this output size was 768. It matches here. This is hidden size. What is this hidden size? This hidden size is the uh, this output of the extracted features, which then can be connected to any other head. So I've investigated the architecture, try to see the output from that, try to reverse engineer what would have been the code of the architecture. So yeah, I kind of like I also confirm whether the configuration thing which is given matches with this or not. Spend some time going through this, trying to build your own understanding of what feels more important. And that way, when you do start using this thing, you will build a lot more understanding of this library. So there are a few terms which I know are important. So vocabulary size is an important term. Okay. Number of heads, number of layers, the label to ID and ID to label, mapping of a word to numeric ID to the word. The hidden dimension, which is where the features are extracted, or dim, what is dim? Intermediate size sometimes is used. So, you will get to know which one are more important. For now, these one are a bit more important. Okay. So then we say the tokenized output, we pass it to the model and we get the output. It has this huge output which has a comes as last hidden state. It is, I've already mentioned what is body output. It outputs the extracted features. That is what it is. And you do not see anything related to head because we have not asked for head. So I can kind of like say, and I can build anything I want on it. So extracted features and the poolers output, they are kind of like this. So you can build your own understanding. Check the code, build your own understanding. Check the code, build your own understanding. So what is batch size? Unterminated string. Where maybe this. Okay, I don't think I should waste time here, but so this is the output being investigated, model's output. It tells us, how many are extracted features. And if we combine them into a single vector, entire sentence, if we combine it to single vector. Here, if you check, sentence probably was of however words it was. Here it has converted into 768 embedding and into four such values, four such vectors. And in Pooler, they have all been combined into one single vector for each sentence, entire meaning has been compressed and condensed into one vector of 768 dimensions. So that is what the output is. And this is what the model, entire model part looks like. So this is the head thing and model output we have seen now.